Binary information is represented in digital computers by physical quantities called signals, which exist in either one of two recognizable states, 1 or 0. The manipulation of binary information is done by logic circuits, which is known as gate. Logic gates are basic building block of any digital system. It is an electronic circuit having one or more than one input and only one output. And the relationship between the input and output is based on certain logic. Let us discuss some gates as logic gates. So first, this is the AND gate. AND gate performs the AND operation, means its output is 1 when all inputs value is 1. It means if any one of the input value is false, then its output is false. This logic AND gate can have n inputs, means minimum 2 inputs and any number of inputs can be there. So n must be greater than equal to 2. You can see a symbol here. This symbol represents two input AND gate. So this indicates two input. These are the two input lines and the name is given to input as A and B. You can give any name, say X, Y, whatever. Then y is equal to Boolean function, say y is equal to A dot B, or you can say A and B, or you simply say A B. So how to make truth table? Now first of all, make the columns, two columns as inputs and outputs. So you can see in a screen, two columns are then inputs and output. Under input columns, divide it again number of columns depending on inputs. So in this symbol, you can see that there are two inputs A and B. So make two more columns under this column as A and B, and only one output column, so mention the name as AB, or you can say y is equal to AB. Then how many possible combinations you can make using two inputs? That says that 2 raised to n means if there are n inputs, then you can make 2 raised to n inputs combinations. Here we have two inputs, so we can say 2 raised to 2, that is equal to 4. So we can make 4 input combinations. So make 4 rows. Then what value you need to enter in these 4 rows? Now see, binary numbers by using 0 and 1. So at a time either 0 or 1. So we can say total 4 combinations are there. So divide that 4 by 2, it becomes 2. So for input A, first 2 row you put 0 0 and remaining 2 rows you put 1 1. Then for value of B inputs, take the value of A where 0 is there and find out how many times 0 is there. So you can say that here 2 times 0 is there for input A. Again divide it by 2, it becomes 1. So for B, put 1 times 0, 1 times 1. So first combination you can 0 0. Second combination you can say 0 1. Same way, put 2 times 1 in the remaining rows of A. So 1 and 1. And then again you can divide it by 2, so it becomes 1. So one time B is 0, another time B is 1. So these are the possible combinations. That means both inputs value are 0, or one of them is 0, other one is 1, one of them is 1, other one is 0, and both can have one value at a time. So these are the possible inputs combinations for two inputs. Now how to calculate AB? Depending on the value of this A and B, you can put a value of AB. If you know the definition, that says that its output is 1 when all inputs are true. Means you just find out from these row combinations a combination where all the inputs have same value as 1. So in this you can see that here two inputs are there, and in this row both inputs A and B have same value as 1. So directly you put 1 under this column, and remainings, for remainings you put 0 0 and 0. In this way you can make the truth table. Let us discuss 3 input AND gate. Right, so symbol for 3 input AND gate, say A, B and C. So Boolean function becomes y is equal to a, b, c, and truth table. So as I said that make two columns, one for inputs, one for outputs. Under input columns again make the number of columns depending on the inputs. Here three inputs are there, so three columns a, b, and c, and one column y equal to a, b, c. Now make the combinations of a, b, c. So three inputs are there, that means 2 raised to 3, which is equal to 8. So 8 possible combinations can be possible. How to insert the value inside this row? So divide 8 by 2, it becomes 4. So for the value of a, 4 times you put 0 and 4 times you put 1. So 4 times 0, 4 times 1. Then for the value of b, for this 4 times 0 divided by 2, it becomes 2. So 2 times b 0, 2 times b 1. Then the value of c, divide these total rows, we are having value 0. So it is 2. 2 divided by 2 becomes 1. So 1 times c is 0, 1 times c is 1. Same way you have to repeat the process. And once you make these combinations, then mention the output column and what value you need to put here. As I said that when all the inputs have value 1, then put output as 1, otherwise 0. So this is the three input and gate. Next gate is OR gate. So it performs the OR operations, means its output is 1 when any one the input is true. Or you can say it outputs is false when all inputs have value as false, means 0. It can have n inputs where n is greater than equal to 2, means minimum 2 inputs must be there. This is the symbol of OR gate. Here you can see that two inputs are there. So this OR gate has two inputs and Boolean function says y is equal to a plus b. Then same with truth table, make two columns as inputs and outputs. Under inputs again make the column as a and b because there are two inputs a and b, and the output y is equal to a plus b. Then make all the possible combinations means 2 raised to 2 is equal to 4. So 4 combinations are like say both at a time both may have 0 value. One of them is 0, another is 1, one of them is 1, another is 0, and both may have a value as 1. Then how to calculate output? So its definition says that its output is 1 or true when any one of the input is true. So here both inputs are 0, so output should not be 1. So we'll put 0. Here a has 0 value but B has 1 value, means any one of the input has value 1, then output is 1. So put here 1. Same way here A has 1 and B has 0. So one input as 1, so put the output as 1. And here both inputs have 1, means at least one of the input has value 1, but here all the values are 1, so put 1. So any one of the input has value 1, you can put the output 1, and when all the inputs have value 0, put output 0. Same way three inputs OR gate. So that is a homework, or you can say that here symbol is that like say a b c, three inputs y equal to a b c, and make the table as ABC 2 raised to 3 is equal to 8. Possible combinations are there as we discussed previously. You can make the truth table. And NAND gate. NAND gate, it is an inversion of AND gate. Means you can say that its output is 1 when all inputs are not 1. Means all inputs have value 1, then its output is 0. It means all inputs are 1, then its output is false. You also can say that it is derived from NOT AND gate. It can have n inputs. This is the symbol of NAND gate with the two inputs. Boolean expressions functions say y is equal to ab bar. So truth table. Make the two columns a and b and one column for output. You can write a NAND b, or you also can write in this way. All four combinations are like say 0 0, 0 1, 1 0, and 1 1. Now where we need to put 1 or 0. So from the definition you can say that output is 1 when all inputs are not true. So from this combination you can say that this is the row where all inputs are not true. Put 1, right? This row is that all inputs are not true, means if any one is true but other one is false, so we can say that all inputs are not true, then its output is 1. Same way here, one is true, one is false, but not all inputs are true, then put here 1. Now here all inputs are true, so put its output is 0, because it says that all inputs should not be true, but here all inputs are true, so its output is 0. So this is the NAND gate. This is the NAND gate with 3 inputs. Now next gate is the NOT gate. It performs NOT operation. It has only one input and one output. It is also known as inverter, means its output is an inverter version of the input. That means if you enter input value as 0, you will get output as 1. If you enter input value as 1, you will get output as 0. So this is the symbol of NOT gate. Here you can see the input A is there and its output Y is equal to A bar. This bubble represents the inversion. Now two columns, because we have only one input, so input A and output is A bar, Y is equal to A bar. So if I say at one time value of A is 0, then you will get output as 1. At another time when value of A is 1, then you will get output as 0. So this is the truth table of NOT gate. Next gate is the NOR gate. So it says that its output is true if both input are false. Symbol here, two input NOR gate symbol. This is the A and B are two inputs, and then Boolean expression y is equal to A plus B bar, and input truth table is A and B, two are inputs, A plus B bar is output, and make the combinations as we discussed. And then you can say when we need to put 1 if both inputs are false. So here both inputs are false, make 1, and in other rows make 0. So this is the logic gate.